Hello, everyone. My name is Jordi Pereira. I work at the Universidad Adolfo Ibáñez in Chile. Welcome to my recorded presentation for my submission to the GECCO Industrial Challenge. And this year, the Industrial Challenge tackled an operational problem inside hospital management. But here, this problem is considered as a black box, so there's no more details on the problem itself. The only important thing is that the black box takes 29 input parameters that are our decision variables, and then using a simulation, the simulation reports a performance measure that is our objective to minimize. This simulation is relatively expensive to compute. It's like half a minute per run. So the result is that the number, the computational budget for the challenge is small. You have to find the best solution in a maximum of 200 runs. So for those 200 runs, the solution space is really large. You have to control 29 continuous variables, and also the objective function is quite noisy. You can see in the lower right corner a few hundred simulations from the same solution to see the large difference between one and another run. To deal with this limited budget and the variability, the proposed method is divided into two phases. The first phase basically is an evolutionary algorithm that evolves a simple probabilistic model. This probabilistic model is a uniform distribution for each variable. And the guide for to evolve this model or this probabilistic model is a fractional design. Basically, we use a Taguchi experimental design, which is very common in many engineering areas. Taguchi design basically samples from the population, creating a fractional experiment. The results of these experiments are then used in analysis of means to find the best option. These best options are then modified the probabilistic model by moving the mean and reducing the range of the uniform distribution. And this procedure is repeated for a number of iterations until we consider that there's no need to continue with it. You have a description in the middle of this procedure, how the method converts. Once we consider that the probabilistic model is sufficiently good, and then we move the search to an exploration or a local search phase. This local search basically divides the budget into two parts using an epsilon rule. It either generates new samples from the distribution to substitute the best known, or it generates a very similar solution to the current one, which is a local neighbor. And given the variability, rather than giving only one evaluation, it uses 3 evaluations and reports the median. The results are very difficult to speak about right now, basically because this is a challenge and I don't know the results yet. So maybe this is a very good idea, maybe it's not a good idea. What I know is that after testing the parameters, IRRACE allots time to both parts of the algorithm, basically between 1/3 and 2/3. It depends on the run of IRRACE, and the method converges to basically the best known solution given by the procedure. And that's my presentation. Thank you very much for listening to me. I will be more than happy to answer your questions during the presentation, or if you want by email. Thank you very much, and see you soon, I hope.